We have a polynomial here, negative 1/3 x squared minus 5x plus 7, and we want to determine the leading term, the leading coefficient, and the degree of the polynomial. Now here's how this goes. The leading term is going to be the term of the highest degree. That's out here. This is 2, 1, 0. So the leading term is this term right here, negative 1/3 x squared. Then, after the leading term, we want the leading coefficient. Well, that's just the coefficient of the leading term. And that coefficient is negative 1/3. And then we want the degree of this polynomial. Now, the degree of the polynomial is going to be the highest exponent that we see. Here's a 2, a 1, and a none. There's a 0 here. So the degree here, the degree of this polynomial is 2. Now, if it's 2, it's called quadratic. And in fact, we've got 3 terms here, right? 3 terms, you see them? This one, and this one. I'll write it. We have 3 terms. It's not part of the question, but I just can't help but say it anyway. 3 terms. Negative 1/3 x squared, negative 5x, and 7. And if there's 3 terms, this polynomial is called a trinomial. So for this polynomial right here, let's determine the leading term, the leading coefficient, and the degree. Now the leading term, I'll write these down. So the leading term is going to be the term with the highest degree. Now this first term here has degree 2. The second term, the middle term, has degree 3. The third term has degree 4. So that's going to be the leading term. So the leading term is x to the 4th. Then the leading coefficient, what is the coefficient? The multiplier of x to the 4th. That's a 1. And the degree is the exponent on the leading term. The highest exponent you're going to see there is 4. Now typically we would write this with the highest degree first. So typically I'd write it like this: x to the 4th plus 9x cubed minus 2x squared. That way I can quickly look at it and see, oh, first term, that's my first term. That's going to be the term of the highest degree. Now, there's 3 terms here, so this is called a trinomial. Here we have a trinomial, in fact, a cubic trinomial. And here's our question. Select one of 4 sketches that follow, one of these 4 down here, that describe the end behavior of the graph. So what does it look like if you keep going to the left, keep going to the right, out to the ends? Well, this is a cubic. Now, cubics, we know, typically look like this. All right, they look like this, or they might look like this. Now, they look like this one here, if the leading coefficient is positive. They look like this if the leading coefficient is negative. So what have we got up here? All right, look at this leading coefficient. The leading coefficient is 3. Now, 3 is positive, so our leading coefficient is 3, which is a positive number. So our picture is going to look like this, all right? What's the graph like this? All right, does it look like this one here? Does it look like this one here? No. You know, it's a cubic, so the ends go in opposite directions. So this one is out, right? That one is out. This one is out because they go in opposite directions. This one here we would have if we had a negative out in front, but we don't. We have a positive 3 out here. So I'm going to claim that ours is this one right here.